Hello friends, welcome to TechCube GATE classes. My name is Professor Vivek Singh Rathore and I am Assistant Professor in Government Engineering College Bilaspur, Chhattisgarh. And in this video lecture series, I am taking Signals and Systems subject. And in this, we have come to Module 2 and we have completed almost 2 lectures in Module 2 also. And what we are seeing LTI systems and in the past 2 lectures in this module I have completed how to calculate response of a discrete time LTI systems. So whenever we will be given a discrete time LTI system, how we can calculate the output. We have seen almost 4 methods how we can do mathematically, how we can do graphically, and then through multiplication wise and tabulation method. Now after seeing this, we will see how to calculate output response in continuous LTI systems. So let's get started. And so uh, so we'll see, we'll write the topic here, that is response of a continuous time LTI systems. Okay, fine. So see, what we want to see here is uh, we are giving an input to a system. Okay, we are giving an input to a system and we are taking output. Let's suppose your input is xt, and let's suppose impulse response of your system is ht, and you are getting output as yt. So your yt will be, as we have seen, x of n, h of n, and y of n, we are will take convolution. So we'll get output response as convolution of input convolve with your impulse response. So see, mathematically what you can write, see, you can write yt is equal to integration from minus infinite to infinite. We need to change first domain in discrete time LTI system. What we are doing, we were changing the domain from n to k. Here we'll change domain from t to tau. So we'll do x of tau. Okay, h of also tau, but h of there n minus k was there, so here t minus tau will be there. Okay, and now then what we will integrate with respect to d tau only. Okay, from tau only, because the domain are in tau only. So what we need to do, we need to multiply and we need to integrate it, so that we can get the response in time domain, that is yt. So this is the mathematical expression for your response of a continuous time LTI system. So see, whenever you are giving impulse input as impulse input, you'll get your output as your impulse response, that is your ht. Okay, so this is also called as convolution integral. Earlier we have seen convolution sum. Okay, we were seeing the sum values. Here we are seeing integral value. So this is also called as convolution integral value. Okay, fine. So the graphical procedure will be the same as that of a discrete time LTI system. What we need to do, see, I will write here as graphical procedure to get your output response, graphical procedure. So what we'll do, first step will be changing your time domain to tau domain. So change your domain to tau. For xt will be now called as x of tau, and h of t will be now called as h of tau. Okay, now second step will be the same as that of discrete time LTI system. We'll need x tau is same only, we'll get x tau, but what you need to do, you will time reverse your h tau, so you need h of minus tau. Third step will be your x of tau will be the same, you need to multiply with h of t minus tau, means see, what you need to do, you need to do tau minus t. Okay, and now you need to do h of t minus tau, like this. So minus tau was there, you need to shift, means first what we are doing, we are reversing it. Okay, reverse, and then here we are shifting. We are shifting in the left hand side or right hand side, in the right hand side, shifting in the right hand side. So ultimately convolution is nothing but multiplication of your original input signal with respect to with the your signal which has been reversed, which has been first changed in the tau domain, and then which has been reversed, and then we have been shifted. Means if something is there like this value is there, and you need to do convolution with this value, okay, 0 to 5 and 0 to 10, let's suppose. So first you need to do you need to keep the value same, only do it domain as tau. Then you need to keep the same, you need to take the reverse value, okay, and the domain will be tau only. And third step will be, you just need to shift once, okay. First you will shift this, and then again you will shift more, and then you will shift more, and then you will shift over, and then you will shift more, and then you will shift more, and then you will shift more. It means right hand side we are shifting this value, h of minus tau. H of minus tau will be shifted right hand side, and each value will be multiplied with this value. So you will get the, after multiplication, you will get the output. That's the simplest way to do graphical procedure. If you want, we can do it for you, because as but this is not required for objective type of question, but I will do just a little bit to just explain you what we are doing. I have actually explained you from the rough thing, but I will explain you just for 2 minutes for understanding, better understanding of the concept. So let's do with this question only. uh, this question was there, actually what we are doing, this was 0 to 5 was there, x of t, let's suppose x of t, and you have been given your impulse response as 0 to 10 h of t, okay. And let's suppose this value is 10, and this value is also 10 value, okay. Now what we are doing, h of minus t, first of all we'll change the domain tau, and then we'll do whatever you want, and then this will be 0 to minus 10 value, h of minus tau will be there, and this value will be 10 only. And then you need to, what you need to do, see, for whenever you are shifting, see, for discrete time, one values we are taking, like n is equal to 0, n is equal to 1, for each value you are taking. Now what we are doing, just shifting it, okay. So as soon as you are shifting the h of minus t in the right hand side and multiplying, what you will get, see, whenever you'll do multiplication of unit step, and unit step means uh, constant value into constant value, you will get a slope, okay. So up till when, see, this value is there. Now I'll tell you, uh, this value was there, h of minus tau. Once you'll do shifting, let's suppose minus 10 to minus 9 will take, at for t is equal to 1, we are shifting, for t is equal to 1, it will be like this, okay. T is equal to 1 means, from earlier it was starting from minus 10 to 0, now it will start from minus 9, and it will go on till 1. Means for t is equal to 1 means h of 1 minus tau, we have done this value, h of 1 minus tau, है ना. Now what we are doing, what we want to do, we need integration, minus infinite to infinite, x of tau, h of t minus tau. Now we are getting 1 minus tau, let's suppose 1 minus tau d tau, है ना. Like this, for different t values it will go on increasing. So now see, if you multiply it, you'll see all these values are 0 only, and this value is something value, but 0 into something is 0 only. So this t is equal to 0, before t is equal to 0, whatever value will be there, if you multiply with this, you will get 0 only. So output will be your, if you see output, I will plot here only output also. Let's suppose this is your tau, and this is your I think t, your t is equal to 0 value, because tau is equal to 0, whatever you can take, but t is the value of 0 is here only. And what we are doing, we are shifting it, and we are calculating the output response. So see, This is your yt. Actually yt you're seeing actually will take not time domain, will take as t yt only, because output will take as yt. Okay, so here the x-axis will be time domain t, and for t is equal to 0, for t is equal to 0, see nothing was there. For t is equal to 0, for t is equal to 0, this signal will be multiplied with this signal, you will get something. See, this value is all in our negative axis, and multiplied with this we will get 0. This is in positive axis, positive is 0. So ultimately for t is equal to 0 you will get nothing, 0 value only. So I'll plot it with 0 like this here. And as soon as for t is equal to 1, as soon as t is increasing, it is shifting towards right hand side, we are multiplying only this value. You can see from green color I am showing, for this value only you are multiplying this value, you will get some output. But these all value, if you will multiply with this, you will get 0 output. Okay, so I'll do it. Okay, I'll remove it. I think from this. Okay, it has been removed. So let's do it. For t is greater than 0, it will move to towards right hand side, and this will be multiplied with this. So whatever output will be there, so see, it is a constant signal. This is constant, so it will go on increasing, it will go on increasing, up till when, see, it is more over increase, more over increase, it is more over increasing, increasing, till what time, when this signal is full, till 0 to 5. Here also -5, till -5 it came, and here also 5 values are there. So 5 into 5 all are set values, so it till that maximum values will be there. And after that, whenever this signal will be after t is equal to, see, after this signal has been going in the right hand side, the area value will be decreasing only, because what we are doing here, we are calculating the area only actually, है ना? Integration of both product, we are getting area only. So in Hindi if I say you कि जो नीचे वाला सिग्नल है उसको धीरे धीरे हम लोग राइट हैंड साइड में खसका रहे हैं और उसका मल्टीप्लिकेशन कर रहे हैं, तो वो t इज इक्वल टू 5 तक ही वो वैल्यूज मैक्सिमम वैल्यू देगा। उसके बाद जब ये वैल्यू इधर खसकना शुरू हो जाएगा तो उसकी कम वैल्यूज बचेंगी, तो प्रोडक्ट जो आएगा वो कम कम आना शुरू हो जाएगा। तो इसकी जो मैक्सिमम वैल्यू होगी वो तब तक आएगी जब वो t इज इक्वल टू 5 तक आएगा। तो दिस विल बी from it will do up till here. Now it will go on decreasing, and if this value is full out of t is equal to 5, this tau is equal to 5, out of this value, then nothing is there to multiply, then again value will be 0 only. So see, the values are here only till t is equal to 5. You can see the values are there, because this small values are from 0 to 5. So t is equal to 5, and then it will be decreasing. So this will be the output of your system, output of your output of the system, in which input was given as x of t, and the impulse response was h of t. So graphically this is to be solved, and see, mathematically also you can write down, because you can write the formula x of tau into h of t minus tau, and you can calculate it. So ultimately, if I'll say you with another question, like in like that only, if I'll say you, see, one signal is like this, and second signal is like this, same only, I think maybe 5, and this is also, let's suppose 10 values there. Okay, and this is unit step into unit step. If we convolve, then what you will get, see, now without doing mathematical, just focus and try to do in mind only. Your this is x of t and this is h of t. So what you need to do, first you need to change the domain, tau tau. Okay, second, what you need to do, you need to shift your signal, your h of tau will be shifted, h of minus tau means this signal will be your from this value. Okay, this value is there. Okay, no problem. And there this is now it will be shifted towards right hand side again and again. So you'll get your output response as from at t is equal to 0, you'll get nothing output. So, and as soon as this value will go on increasing, so you will get your output response as this, and it will go on because this is unit step. So it will go on, go on, and it will go straight wise. So from this equation you can, or from this question you can understand that whenever unit step is convolved with unit step, you will always get a, I think you can answer before me, you'll always get a ramp signal. So ramp signal will be generated when two step signals are convolved with each other. So, and yt you can write also, yt you can write, see, you can see the values here. Yt will be equal to mt plus c. From mt you can directly calculate what will be the m, but product of these two numbers are there, that will be your m values. So that you can do whatever you want. If you want to see in mathematical expression, or you want to see in the graph, you can directly put it the values. So see, nothing more than that. Values are there. You can calculate the output of a continuous LTI system very easily by this type of graphical procedure. Now we'll solve it by some other method, but before that I wanted to tell you one thing more. See, if you can see, whenever we are convolving any signal ft with unit step, what we are getting actually. So if you see, ft is convolution with unit step, what we are getting, we are almost getting the, see, this signal was convolved with this signal, this is unit step signal only, okay. uh, Unit step, but maybe gate pulse you can say. But if you can see, this signal xt was convolved with this signal, that is unit step signal. What you are getting integration of this value, okay. Somewhere you are getting integration because whenever two unit step signals are there, or one normal signal and another is unit step signal, and when we are convolving, let's suppose this value is there, okay. This value is there, 0 to 5, and this 10 value is there, it is convolved with maybe this value, okay. 5 value is there, and this is your h of t will be there, this is x of t. Whenever a signal is convolved with unit step signal, you should remember it, that first what we are doing, we are just will do tau domain, and will reverse it h of minus tau, and then we'll shift on, it will go on shifting to the right hand side, and multiplication is there. So what we are getting, will get response as this value till when, up till when this value will come till 5, till 5 value it will go on increasing, and then suddenly the values will go on decreasing, because only this value will be there, less value, and actually this value will be go on, like, see what will happen, you can see, this value is in till minus infinite only. So this value will go on increasing only, till whatever value will be there, this is multiplied with this value, so it will go on increasing, and till 5 it will be go on increasing only, okay. So it will go on increasing, but after a certain value, this value, the value will remain fixed, and then it will become constant. So ultimately what is happening, if you will do integration integration of this signal, you'll get the output as same. So what I was about to tell you, that any signal when convolved with unit step signal, you should remember that it is always same as integration of this signal f of t dt, okay. So till whenever your t was there, till that it will integrate the value. So whenever your values are given, uh, if you want to do, if you have been given the question ft is convolved with ut, you can integrate your signal from minus infinite to t of ft. You will get the same output as you are getting from this input. See, by this method we can do some questions also, like, uh, see, if question is there, e to the power minus at ut, okay, and you have been asked to convolve with ut, what you are going to do? Are you going to do by graphical procedure or simple? If you can do any signal convolve with ut, you can do minus infinite to t to the power minus at ut dt, simple. And now see, ut is there, so what we can do, we can do 0 to t, because ut, any signal multiplied by ut means from t is equal to 0, the value will be 1 only. So any signal multiplied with ut, it will affect, it will occur only after t is equal to 0. So you can do 0 to t to the power minus t at and dt, and there you can do e to the power minus at is e to the power minus at by minus a, and it is 0 to t, 0 to t, and it will occur like minus 1 by a common, e to the power minus at minus 1. So it will be like 1 minus e to the power minus at by a. This will be your answer. So see, mathematically also convolution with ut is very easy, or just integration only you need to do. And now see what happens when any signal is convolved with impulse signal. So see, if ft signal is there, any signal is there ft, if it is convolved with delta t impulse signal, or shifted signal like delta t minus t naught or something, anything, what will happen? Because see, I have already told you in starting only, uh, delta t is identity signal, it is just an identity, so it will create only ft only, okay. And see, for delta t minus t naught, you will get ft minus t naught. This value will be uh, come here, okay. I have told you in, I think, discrete time also, the same thing happens in continuous time also, okay. Okay, so whatever signal may be, if ft minus t1 is there, convolved with delta t minus t naught will be there. So what you will get, this value will come across this value, so you will get ft minus t naught minus t1, okay. So like this convolution will be there. See why I have told you this convolution, because it will create the procedure easy, okay. So let's see, uh, I will tell you another method how to do convolution using differentiation method. So we'll see our next method for doing for getting response of a continuous LTI system. So we'll try out differentiation method, okay. Differentiation method, how we'll do? See, up till now what I have told you, I have told you one method that we can do minus infinite to infinite, f tau will be there, h t minus tau will be there, and d tau will be there. If you can do integration of this, and then you can get your output as y of t. First method I told you like this. Second method I told you that if you are not comfortable with this, you can do graphical method. So you'll change the domain and you'll reverse it, and then we'll shift it, okay. So second method is graphical method, which we have seen earlier also, okay. Now in that only I told you that okay, from here we can do, if your ut is there, then you can integrate it. Third method, differentiation method, what we can do is, see, uh, output what you are getting yt is nothing but your input convolution with your impulse response. This is the thing which we are seeing. If we are doing differentiation, let's suppose any differentiation in any of the signal, let's suppose ft is there, and differentiation you are doing dh of t dt, okay. And so one differentiation here, it will also come d by dt dy by t, okay. So uh, if you are not able to do this type of convolution graphically, and then but you are able to do this type of convolution, so whatever you do convolution, and then you can integrate it, you will get your output, because here d by dt is there. So when after that, if you are going to do ft convolution with dh by dt, and then you are going to integrate, then you will get your output very easy. I will show you with one question. One question we'll see. Let's suppose this question is there. Let's suppose this type of graph is there, okay, and let's suppose this is value is 0 to 2 values there, okay, and the values are 5. This is, let's suppose your ft signal is there. If you have been set to convolve this signal with this type of signal, let's suppose this is also, now t is there, and let's suppose this is also 0 to 2. This is your h of t. Now you have been asked to convolve these two signals. Earlier what you used to do, you used to shift your reverse your h tau, and then you need to shift it and then multiply, you'll get something continuous ramp, because both signals are constant, so you'll get like that. Okay, that is fine. Now the more easiest way how we can do. See, as you know, as we know that yt dy by dt can be represented as ft convolved with dh by dt. So can we do differentiation of any of the signal? So let's do differentiation of dh by dt. What you will get? You will get differentiation is t is there, the is there. So let's do it here. See, this is unit step. This can be represented as 10 u of t minus 10 u of t minus 2 is there. So we'll get 10 of 10 of 10 delta t. Okay, we can write here, I think 10 of delta t minus I think 10 of 10 delta t minus 2, that we can write. See, now this is your dh by dt. What we are doing, we are convolving with your ft. ft is nothing but 5 of 5 of ut minus 5 of ut minus 2. Okay, this is there. Now you need to convolve. I told you just property that whatever signal is there, if you are convolving with this 10 delta t, so it will act as your identity signal. So 5 tens are 50 and ut will be there, okay, and then will be 5 tens are 50 ut minus 2 will be there, as I have told you earlier. Here you'll see minus 50 ut minus 2 will be there, and you'll get minus minus 5 10 50 ut minus 4 will be there. So you'll get your output as 50 ut minus, see, minus minus plus, so minus 100 ut minus 2 and plus 50 ut minus 4. So okay, I think you'll get your output as you'll get your output as like this, 50 ut. So it will go like 50 ut minus 100 ut minus 2. So 50 here and 50 here, 100 ut minus 2, and then again ut minus 4 at t is equal to 2, t is equal to 4, you'll get here. So this is your output, not fully output, but this is your, I think, dy by dt you have got, because earlier what you was calculating, dy by dt is equal to ft convolution with dh by dt. So you have got dy by dt. Now you need to, for integral, I have told you in module 1 only that how to integrate your unit step signal. You'll definitely get your unit step signal, like, see, I'll do it here only. So see, I'll do with, I think, blue pen. Okay, so see, 50 ut is there, it is going on, and till values are going on till t is equal to 2. So it will go on like this till t is equal to 2. Your the constant value is there, I think 50 value is there. So uh, it is constantly integrating, okay, the same value. Like, see, only one values are there, so 1 plus 1 2, 2 plus 1 3, 3 plus 1 4. Constant value, if it is there, if you are adding, it will go continuously increasing. How much till it will increase? It will increase till your t is equal to 2. Okay, at t is equal to 2, suddenly the value decreased, and then suddenly your negative value came. So negative value came means it is decreasing, until where it will decrease, till this value I think this value will decrease. Okay, so it is a flat curve like this, and the values are see, the slope is there, the 50 value is there, so it will be your slope value. Slope will be 50, and here slope will be the value here minus 50, so minus 50 will be there, the slope. So what will be the final value? Final value, you can see the this is value is y2 minus y1 is 0, and x2 is what is x2 at t is equal to 2, so 2 minus 0, and the slope is 50, so you can calculate y2 is equal to 100. So this value is your, actually this value is your 100 value. So finally your output is this. And how it came? It came by just differentiation property we are using, and we are getting the output like this. Okay, so you can already write it also like this, that 50 ut is there, integration of ut, you know, rt is there, so 50 rt is there. What you'll write 50 rt means the change of slope, so slope is 50 and here the slope is 0, so you'll get final slope minus initial slope, you'll get 50. So 50 rt you'll get, minus 100 rt minus 2, if you'll see, minus 100 rt minus 2, so minus 50 minus 50 minus 100 only, so minus you can write it here if you want to write this expression by rt, because I have told you in unit module 1 also, I have told you in initial lectures that how to write this signal. If you are unable to do it, please go through that video and see how to integrate the signal and how to write the expression of unit RAM signals, because those lectures are useful in this also. So definitely you can do it. Very simple question is there. Convolution of two signals are there. What I have done nothing, just I have done dy by dt is equal to ft into convolution with dh by dt. Just one signal you can do in impulse, and if one is converted in impulse, just you will do multiplication. Definitely I told you that any signal ft is there, if it is convolved with delta t minus, let's suppose t naught is there, it will definitely come ft minus t naught, simple, no problem at all. Okay, so this property can be used here. Okay, I think this now you can understand very much easy now. Okay, so I think one question I will give you, and you should, I think you must have joined Telegram channel, so you must solve your answer, and please upload your screenshot there. So I'm giving you one question, like same question only. If I'm giving you from 0 to 4 values there and 5 values there, you will get your output as not output, a second signal. If you are convolving, you'll take as, let's suppose, 0 to 5, maybe 0 to 6 values there. Okay, and now you check, let's suppose 10 values there. You do integration, you do convolution, and please upload your answer in Telegram channel. We'll see it if any problem is there, and I'll solve it if problem comes then. Okay, so see, I will tell you answer, because maybe answer you can for checking answer you can see solution there only, you need to upload. See what will be answer. If you'll see, when we'll convolve, here it will come from 0 to 4, and it will come like a trapezoidal signal, and it will go like this, and the value will be 0 to 4, and here maybe 10, so here maybe 6 value will be there, like this value. It is a trapezoidal signal. I'm not it is looking like something else, but it is a trapezoidal signal, and the value will be, I think, slope will be equal to slope will be equal to 50 slope value will be there. So you can calculate this value at this point and this point, same value, and here also slope will be minus 50. Okay, so see how I have done it. See, I have not solved this question, but definitely I have told you the answer without seeing. How I am able to do this, I will tell you, but please, I am suggesting you, please pause the video and try to solve this question. After you are getting this answer, then only you should proceed further. Now I am telling you how to get this type of answer within a fraction of second, and no need to solve and no need to pen down also anything. Just see, I'm giving you again one question. This question, maybe we'll see from this question only. uh, when two signals are there, okay, when two signals are there and both signals are of same time axis or same duration, 0 to 2, 0 to 2, same duration is there, means not 0 to 2, 2 time means 2 time, if you say 2 second, so it is 0 to 2 second, means 2 second duration is there. Here also 2 second duration is there. When duration of the signal is same, then definitely the convolution will be triangular triangular only, output will be triangular. So you have got output as triangular only, hai na? Second thing, so we are taking conclusion actually, because after solving many questions we have got some conclusion which are very useful for objective type question. Like, see, first conclusion is when two signals are convolved with same duration, okay, with same duration, and both are pulse only, when two pulse signals are convolved with same duration, output will be definitely triangular pulse. This question has been asked many times in the exam. When two pulses of same duration are convolved, what is the output? It will be triangular only, output will be triangular only, but what will be the duration? So second conclusion we have got, let's see our answer is, see, this value have been started from 0, and this value was 2 and this value was 4. So if you see the input 0 to 2 convolved with 0 to 2, so the output is 2 plus 2, 4, and input is 0 plus 0, means your input means output is starting from 0 only and ending at 4 only. It means that whenever a two signal is convolved, so the initial value will be this value plus this value, so it will be 0, and the final value will be this value plus this value will be final value, 2 plus 2, 4. So this value will be final. So second conclusion will be your initial value of your response will be sum of initial value of the both signals which are convolved, and the same with the output final value also. Okay, so second conclusion you can understand. Third conclusion what we have got is the slope value. So you can see the slope value was here 50. So how it came 50? Because this value was 50 only, so at every point we are increasing 50 50 50 50, means slope is 50 actually. So let's see what how we got it 50. See, here values are, I think here values is 5 and here is 10. 5 tens are 50. So somewhere we got slope 50. So this is our third conclusion is, whenever we need to calculate our slope, this slope value is there, we need to calculate. Then whatever this value is there, let's suppose this 4 value is there and this is 5 values there, so 4 5s are 20, so slope will be 20. So third conclusion will be slope value should be equal to product of both signal magnitude, both signal amplitude. Okay, so I think the conclusion which you can get is, uh, first is the width of the signal. Width will be how much? Width will be total this width plus this width. Okay, so total width of your output signal will be width of first signal plus width of second signal. This will be your total width, I can understand. So, and one more conclusion if you can draw is your area. Okay, so see, whatever area will be your first one, total final output area, if you can know, uh, area of first signal multiplied by area of second signal will be your total area. Like, see here, your area is 4 into 2 8. Okay, so here I will write my area will be 8. here is 5 into 2 10, so area 2 will be 10. So what will be total if you product it 8 into 10 80. Okay, so let's see output area. Output area not is equal to half into base is 4 into height. What was height? Height you can see slope is 20 only na, so you can calculate y2 minus 0 by x2 is I think t is equal to 2 na. So 2 minus 0 is equal to 20, so y is equal to 40. So you'll get 2 the, so total 80, area is equal to 80. So finally you can get your total area of output signal of output is equal to area of input multiplied by area of your impulse response. This conclusion you can understand. Okay, I think you have understood. This conclusion also you can understand. We need to calculate actually slope, and slope can be calculated very easily. You just need to product, you just need to multiply this amplitude and this amplitude, you'll get the amplitude. And width also you can get, total width will be this width plus this width, and total width will be this plus this. But this I have told you when both signals are in same duration. What will be there in when different durations are there? So we'll see one question like this. I have given you homework also, the same question. 0 to, let's suppose 2 is there, and product amplitude is 5, and if I have convolved with 0 to maybe 0 to 4 will be there, and amplitude is I think 10. So when we are convolving two different duration signals, okay, then what will happen? So definitely you need to remember it, that whenever two different amplitude pulse signals, okay, pulse signals are convolved, you will definitely get a trapezoidal signal. So both property you need to remember. If duration is same, you will get triangular, and if it is different duration, that is why I have wrote this answer directly as a trapezoidal. This will definitely come as trapezoidal signal. You can directly from mathematically also you can plot, but I will tell you shortcuts also. So see, trapezoidal, how we'll plot it? We'll plot like this. Trapezoidal is there. Okay, uh, I told you what will be the initial value of output. Yt output initial value will be this value plus this value, so it will start from this value only. So I will mark it here, at this value it will start, and end how much? This value plus this value, so 2 plus 4 6. So at t is equal to 6, I think 1 minute. Okay, so for output we'll calculate this value. Okay, um, okay, 1 minute. It is not coming. Here it is there. So see, at t is equal to 4 plus 2 6. So our we got that what will be the initial point and what will be the final point, and we'll get trapezoidal. So trapezoidal, we can plot. Trapezoidal is nothing but one straight signal is there, and then you'll get a slope value like this value. This is trapezoidal signal, which is having a some value, some slope, initial slope, then constant value, and then some decreasing slope. So we need to get this value also, where it is actually increasing and where it is getting constant. So you need to see wherever, whichever the signal is of small duration. Just remember, whichever signal is of small duration, that will be the duration of the increasing slope or decreasing slope. So small duration is 2 only, so you will write here 2, t is equal to 2, means time duration is 2 seconds na. So we have taken from t is equal to how much, 2 seconds will come, t is equal to 2. Now this also this is also decreasing slope, so here also 2 duration will be there, so 6 minus 2 will be 4, so t is equal to 4 will be there. Okay, this value came. What will be the slope value? Slope value will be product of both, so 5 into 10 is equal to 50, so 50 will be there. Slope here also, slope will be minus 50 will be there. Okay, this value, what we need to calculate? This value. This value you can definitely calculate. See, for t is equal to 1 time it is coming, slope is increasing 50. So for t is equal to 2 it will go to 100 definitely, so it is value is 100. Now what you need to do, you have calculated almost every value. So here also same thing will be happen. This total, this width plus this width is equal to total width, this area into this area is equal to total area, and this into this product will be the value of slope, and everything apart from this triangular pulse, the conclusion which we have drawn from here will we are getting here also. So maybe this solving technique you must have understood and you must have known it. In the next class I will deal with some of the different types of property which LTI systems follow, like what are the differentiation property, and what are some commutative property, associative property, distributive property, and all. So we'll discuss in the next lecture, and we'll try to close up this continuous time LTI system there. And if it is not, then we'll see in the next lecture. But for this lecture, this much only. If you have liked the video, if you have understood the video, actually not liked, if you have understood the video, and if you are feeling confident enough to solve some questions and getting some concept, then please do like it, share it with those students who are in need of it, because as I am telling you in the always every lecture, that it is a free of cost service which we are giving apart from our college work. We are all TechU faculties, we are working in different colleges, and we are working there. So we have lots of work, we have lots of portfolio to manage, and then we are taking out our personal time, and we are preparing lectures, and we are delivering it. So if you are like it, then please do comment it, and tell your feedback. It is if it is positive or negative doesn't matter, because and if negative is there, then we'll try to improve it. That is our good point only, and if it is good, then it will motivate us. So okay, till then, tata, bye bye, see you, have a good day, Jai Hind, Jai Bharat.